Recording. All right. So the next example, now that we've done like all the preliminary stuff, we're going to get to where I think we spent a lot of our time in this semester. So I want you to, I'm going to simplify x to the third plus 10x squared all over x squared plus 2x minus 80. All right, so you're simplifying. You have a rational expression. That's just fancy language for a fraction. And we know to simplify a fraction, we need the factor. So hopefully you have your factoring flow chart with you. First thing I'm going to do is look at the numerator. I'm going to look for a GCF. I could factor x squared. All right. And then down below in the denominator, that is, there's no GCF. It's a trinomial with a 1 out front. So I'm going to go directly into my binomials. I do my signs first. Now, what's nice about this here is this. I know the next thing we do is we're going to write out the factors of 80. And I'm going to do that, but I'm going to show you something. So 1 in 80, 2 in 40. Let's say 4 in 20. 5 and, is it, what are we at, 80? So 5 and 16. 8 and 10. Now, here's what's nice about this. The answer is kind of staring you in the face in terms of your factoring. And what I mean by that is this. The directions are simplify. You know that I want you to reduce things. That's my goal, is for you to reduce this. You already have an x plus 10 in the numerator. So chances are that factor is going to be x plus 10 as well, because I want you to reduce that. When we go ahead and factor this, we know we write out the factors. We look for two numbers that combine to give you plus 2, which is in the middle. And you know, because you put your signs first, one of them is positive, one of them is negative. Well, that's going to be negative 8 plus 10, which equals positive 2. So just by understanding what I want you to do, which is reduce, it can kind of help you factor quickly. Because you know, or at least you're thinking, that x plus 10 in the numerator, chances are I'm probably going to reduce that. And in this case, I totally am. So I'm just going to go ahead and just reduce them. And I write what's left over. X squared over x minus 2. Does that make sense, everyone? Yes or no? Now, I don't know if I showed you this. I can't remember, but I'm going to show you it anyways. All right, so here is the practice exam. All right, and I typed in the answer. Okay, then I don't know what you do. I just hit enter. All right, and I see that it kind of like locks it in. Do you know what I mean? Now, the reason why I'm showing you this is because this practice exam has 36 questions. I think your final exam also has 36 questions. Okay, if I hit this down arrow in the middle. What number is this? 12. Oh, wait. I got to go to the next problem. That's why. All right. So if I hit this down arrow, notice next to the number 12 is that gold ring like in Sonic the Hedgehog. Okay? The reason why I'm showing you this is because I'd rather you do 30 good problems than 20. I spent way too much time on question 12, so now I only finished 20 problems versus 30. Does that make sense? You got to remember, this covers the entire semester. So if you don't know how to do something, like if you don't have an idea, just move on to the next problem. Once you get like to the end, okay? Once you get all the way down to like 36 and you do 36, you can just hit this and go, oh, okay. All the ones with a gold ring, you've already done. The ones with nothing, like question 1, 2, 3, 4, 5, all the ones I didn't do, they're not going to have anything next to them. So I wanted to show you that because sometimes people think I can't go backwards. Yes, you can. All right. Using the arrows on either side to go backwards is boring. Work smarter, not harder. Click this so you can see the test overview and say, oh, okay, here are the ones that I need. Does that make sense? Okay, good. I just wanted to make sure I showed you that because I had a student the other day and he didn't know you could do that. He thought it was the greatest thing ever. And I was like, well, yeah, you could do that. All right. Now, here comes what I think is one of the best problems on the practice final, and you're going to see this on the final exam itself. So we got 8 times n squared minus 50. Let me write that better. 2n squared minus 7n plus 5 divided by 14n squared plus 31n minus 10 all over n squared minus 7n plus 6. Okay? So first thing I do, I see 2 rational expressions. I'm dividing. I'm going to make sure everything's in descending order. And then since I'm dividing, I'm going to rewrite it. So I look. Everything looks great. So I'm just going to rewrite it. Write the first rational expression. Division changes the multiplication. And I multiply by the reciprocal. All right. Now, for me personally, I will factor all the easy stuff first. I know I need to factor everything, or at least attempt to, but I'm going to go ahead and do the easy stuff first. Now, what makes this problem so good is the very first factoring that we're going to do. So I'm going to go ahead and just draw a line. This is just my scratch work over here. And the first one I have is the 8n squared minus 50. So, first thing, I look for a GCF. We have one. It's a what? Excellent. A 2. So that gives me 4n squared minus 25. Now, am I done? The answer to that question is no, you are not done factoring. And that's what makes this first factoring so important. Because if you look at what's inside the parentheses, that is difference of squares. Notice you have 2 terms, you have a minus sign, and that n is raised to the second power. So the only thing that we really need to be concerned with is 4 perfect square, is 25 a perfect square. And they are. So 2n plus 5, 2n minus 5. I told you, I'm going to hide that difference of squares somewhere in the problem. It's going to be there. So make sure you're aware of that. All right, so there's the numerator. Are there any questions with that? All right, so I'm going to go ahead and I'm going to move over to the next fraction. And I'm going to do that numerator as well because it's easy for me to factor. I notice there's no GCF, 3 terms, leading coefficient of 1. So I just need 2 numbers that multiply to get 6, combined to give me negative 7. And because I put the signs in first, I know they're both negative. That's as easy as it gets, 1 and 6. All right. Now, here comes the fun part. The 2n squared minus 7n plus 5. Okay? So we're going to go ahead and we're going to factor that. And we know, just by looking at that, there's no GCF, 3 terms. However, I have a 2 as a leading coefficient and not a 1. So I got to use my AC method. So 2n squared minus 7n plus 5. I get my idea. I notice that they're both going to be negative. Okay? So from here, excuse me, 2 times 5 equals 10. I write out the factors. 1 and 10, 2 and 5. I know they're both negative. So that's going to be negative 2 minus 5 is negative 7 to combine to give me that middle term. So from here, I rewrite it as 2n squared minus 2n minus 5n plus 5. All right. Now I factor by grouping. So 2n squared minus 2n grouped. The minus sign is in the middle, so be careful about your second sign. Has to change. And then from here, I go ahead and just factor out the little mini GCFs. So the first one's going to be 2n. So that's going to leave me with n minus 1. And then for the second grouping, I could factor 5 out to give me n minus 1. I know I'm right because the parenthesis binomials are the same. So I get that n minus 1 out front with the 2n minus 5 in the second binomial, and I'm going to write that directly underneath. All right. How are we looking so far, everybody? You out of here?
I'm out of here.
Deuces.
Deuces.
What's up for tonight? I forget.
Did you save the aloe?
Yeah, I cleaned it all up.
I'm going to fix that when I get home.
Then you have a job.
I think 6 o'clock.
Tonight?
Yeah.
Honey, you don't get home until like 5:30.
No, I'm off at work at 4.
Okay.
I love you.
Love you too. Anyways, so now we need to factor the last one, okay? So we're going to be smart about this. And what I mean by that is, you know, my goal is to get you to reduce things. You also know, in order for me to reduce, I need to have the same stuff in the numerator as the denominator. So I can already see the n minus 1s reduce. The 2n minus 5s reduce also. I could see that right from here. So I'm betting you. I'm just going to say, whatever this happens to be, I bet you one of them is going to be either 2n plus 5 or n minus 6. Or both. Okay? So 14n squared plus 31n minus 10. Excuse me. Now, there's no GCF here. And this one is actually gonna stink to do. All right. So let's get an idea. A plus and a minus. And this is why this one stinks. It's because 14 times 10 is 140. All right. Now, if I were you, I would not hesitate. I wouldn't take my time. What I would do, and I'm clicking on it right now, is I would just get out my calculator right here. And the reason why I'm saying that is because I know there's going to be a bunch of factors here. In fact, 10 times 14. And remember, you're looking for the pair that gives you positive 31. All right? So let's see here. 140. Now, I know a 3 is not going to work. Will a 4 work? Yep. 4 times 35. And if you look, I'm going to stop right here. Because what I know is they need to combine to give me 31. Okay? And one is positive, one is negative. Negative 4 plus 35 is 31. So I'm feeling really, really good about myself right there. Okay? So I'm going to rewrite it as 14n squared minus 4n plus 35n minus 10. And like I said, we're going to know if we're correct very quickly. Let's group. Out of the first grouping, I can factor out, what does it look like? Looks like I could do only a 2 and an n. So that's going to be 7n minus 2 plus. Now that second grouping, I can factor out a 5. And that's going to give me 7n minus 2. And what do you know? The 7n minus 2 binomials match. And you're left over with a 2n plus 5. Perfect. So the hardest part about this problem was just knowing how to factor. Now from here, I'm just going to look for numbers that are the same in the numerator and denominator. So let's see here. 2n minus 5s, I said they reduce. The n minus 1s, they reduce. The 2n plus 5s, they reduce. And that looks like it's it. So 2 times the quantity n minus 6 in the numerator and 7n minus 2 in the denominator. I think, if I'm not mistaken, that is going to be the most time-intense problem. And it's because you just got to factor everything. Okay? Are there any questions? All right. So let's just recap real quick this whole factoring thing. All right? You got to remember the flow. Look for a GCF. Count the number of terms. If it's a binomial, you got formulas for that. If it's a trinomial, you got 2 options. Either the leading term is 1 or the leading term is not 1. If it's not 1, AC method, that's the toughie. If there's 4 terms, factor by grouping. So I'm telling you right now, you are going to use that entire flow chart. Like, I'm just looking at the examples, and you will use that entire flow chart on the test. So make sure that you have it either drawn on a piece of paper or you printed it up. Okay? If you forget where it is in Blackboard. Okay? Are there any questions? All right, let's move on then. Let's move it on up to the east side. Notice my pitch perfect tone. It is absolutely horrible. If it was life or death on me hitting a note, I would be dead. My wife, she's an amazing singer. She sang for years, and like she sang in her church for years. She did like soloist stuff. I mean, she's an unbelievable singer. And I sing, and she just does nothing but makes fun of me to my face, which is even worse. Like, do to the side, like, to your mom, like, hey, he's not a good singer. Do you know what that's saying? No, she does it to my face. Anyways, here we go. Let's factor. Now, first things first, look for a GCF. There is a GCF here. It's a 7. So I'm going to factor it out. The result inside the parentheses is x plus 3. Or, I'm sorry, x cubed plus 8. And remember, you got to ask yourself, can that be factored? Number of terms, 3. Look at the variable. It's going to give you an idea which one it is. The variable is a cube. So I'm thinking sum or difference of cubes. How do I know which one? I look at the sign in between. It's a sum. So the formula I need is this right here. So there's my formula. The only thing I need to be concerned with, What cubed equals 8? And that is the number 2. So I look at my formula. I'm going to put a big fat 7 out front because that was my GCF. And then all I'm going to do here is just substitute. I'm going to be careful. So I get x plus 2 times the quantity x squared minus. Now, I know this is going to be, I know it's going to be x times 2, but I'm going to write it as 2x plus 2 to the second power. And 2 to the second power, remember, is 4. I don't know about you, but I wish the entire final was similar to a problem like that. Because there was no thinking. Very little thinking. It was all just use your formula. Okay? Are there any questions? All right. Now, I have this sneaky suspicion that Courtney is making fun of me because she's constantly laughing.
No, I'm not. Because my daughter was like, your math teacher's funny.
I know I'm funny. I'm very funny.
Dad's in the kitchen laughing. So I'm just laughing because everybody else.
Can Dad hit it? Can he hit a note? Can he sing? No, he's like me. Oh, it's horrible. I mean, and I am the type I will.
I am like your wife. I'll just tell him.
Oh yeah, no, I will sing so loud because maybe I like the song. And then she looks at me dead in the eye with the most serious face. She's like, "Don't sing. It's just not good." I'm like, "Oh, jeez, thanks." April, can you sing? Don't worry, I'm not going to ask you to sing. I'm just asking, can you sing?
I was in chorus in my high school, but I don't know. I'm not great.
I tell you what, let's get through this. Let's get through a couple of these examples, okay? Obviously, I'm going to let you out around 9 o'clock. Oh, there's Batman. I'm going to let you out around 9 o'clock. If you want to hear a very funny story, and it's one of the most embarrassing stories of my high school career, I will tell you it. If you want to stick around, it's totally up to you. So I'm going to do it after class, all right? I'll just let you know what it's about. I tried out for the High School Musical, and I made it. All right? I had a lead dance role. But there's more to the story, and it involves singing. So if you want to hear it, you could stick around and listen to it. But right now, what I want to do is I want to solve this problem, okay? Now, I do want to go over this because I think sometimes we are so fast to just dive in and start solving that you need to slow yourself down. You really need to slow yourself down. And this is what I mean. What type of problem do I have? Now, to help you, here are the types of problems that we examined this semester. We examined linear, quadratic. We examined absolute values, inequalities. I mean, these are all the types of problems that we looked at. And depending upon what type of problem you have, linear has certain steps, quadratic has special steps, absolute value problems have special steps, inequalities share the same steps as linear, but it also has something special about it. So, what type of problem am I looking at here? Because I think that's the most important part. Because once you determine, oh, it's this, then you know what to do. So what type of problem do I have?
I'm gonna guess.
Go for it.
Is it just linear?
It's just linear. And how do we know that? I look at the n and the n, and they're both raised to the first power. So I know it's linear. Which means, step 1, Do I see fractions? No. Step 2, do I see parentheses? Yes. Distribute. So you have 15n plus 5 equals 72n plus 9 plus 3. So step 3, look on the left, combine like terms. I can't. Look on the right, combine like terms. I will. So I get 15n plus 5 on the left. There's nothing I can do there. But that 9 plus 3 on the right-hand side of the equation, I can group that together. 72 plus 12. That's pretty nice. All right. So now step 4. Excuse me. Step 4. Get the variable terms on one side, constant terms on the opposite side. Okay. So I'm going to go ahead and subtract 15n from both sides. So 72 minus 15 is 57n. And now I will get the constant terms on the opposite side. 5 minus 12, negative 7. Yeah, did I make a mistake?
Wouldn't it be 63 yet?
72. I'm using my calculator. Minus 15. I'm coming up with 57.
No, I meant 9 times 7.
Oh, so I did make a mistake. Oh, yeah. Why did I put 72 down? For everybody wondering, I'm going to highlight the mistake so you know what to change. Thank God. Thank God Jay's here. Jay, did you get my email?
Yeah.
I'm ready when you are. Except Saturday night. That's a bad night. So, real quick. Now, I fixed my mistake. 9 times 7 is 63. For some reason, I did 9 times 8. So, 63 minus 15 is 48n. So I still get 5 on the left equals 48n plus 12. Now I will subtract 12 from both sides to give me negative 7 equals 48n. And then step 5, I divide both sides by the number in front of the variable, which is called the coefficient. And we get negative 7 over 48 equals n. Okay? Are there any questions there? All right, good. So far, so good, I guess. So my next problem is another solving problem. All right, so we're going to solve 20y equals 25y squared. Now, once again, I'm going to ask the question that I did in the previous. What type of problem do I have? Is this linear, quadratic, absolute? Is it an inequality? What is it? Excellent. It's quadratic because of that right there. We know on the left-hand side, we have 20y to the first power. That's okay. It's the highest exponent. It's the largest degree. That is going to determine what type of problem you have. So since this is quadratic, I have a completely different set of rules that I do. So with quadratic equations, we set them equal to 0 first. So what I need to do is subtract 20y from both sides. That gives me 0 equals 25y squared minus 20y. Now, the reason why I chose to move the 20y instead of the 25y squared is because the 25y squared on the right is already positive. So I'm just going to leave it there. I'm going to bring everything to that side. That's just the easiest. If the 25y squared was negative, like negative 25, I would have moved that to make it positive. All right? From here, second step, factor. So, do we have a GCF? The answer is yes. I think it's going to be 5y. I'm left over with 5y minus 1. Okay? And then the third step, you take every variable factor and you set it equal to 0. So if that factor contains a variable, you set it equal to 0. So we get 5y equals 0, or 5y minus 1 equals 0. And what's nice about this, they're like two little mini problems. And you just solve them independently. So for the first, we divide both sides by 5. And that gives me y equals 0. And then for the second, you add 1 to both sides. And then you divide both sides by 5. To give you y equals 1/5. Okay, are there any questions there?
The one before, I have 4/5.
4/5.
Yeah. Tried my in
Oh, dude, I made another mistake. Yeah. When I factored, this should have been a 4. Man, I'm having a hard time today. Can I use the excuse it's Friday? So everywhere where I highlighted should be a 4. When I factor out 5y, it's 4. I did this problem yesterday, but it was different, and it turned out to be a 1. So I remembered it from yesterday. All right, let's do a couple more. Galileo, what are you doing over there? Come on, keep moving. Keep moving. All right, next one. Yeah, we'll do this one. We'll do the hard one. All right. So for this problem, notice we got rational expressions all over the place. Oh, and that's another type of problem we looked at. I didn't even write that one down. So we looked at linear, quadratic, rational, absolute value, and then there's inequalities. Wow, we looked at a bunch. I forgot about the rational ones. So, this is rational, which means the first step that you need to do is get rid of the denominators. And how do we do that? We got to find the LCD. Our LCD is going to equal the product of unique factors. In this case, it's x plus 2 times x minus 2. Artie, what are you doing? All right. So I'm going to go ahead and I'm going to multiply every single term by my LCD. All right. So just give me a second here and I'm going to write it out. X plus 2, x minus 2. And then 7x over x plus 2. minus x plus 2x minus 2 times 7 equals x plus 2x minus 2 times x minus 22 over x minus 2. All right, I'll give you a minute to write that down because I know it's a lot. Okay. Now, the whole reason why we are multiplying by the LCD is so we can remove or eliminate, reduce, however you want to say it, denominators. So if I start on the far left, I know the x plus 2x minus 2 is really over 1. So I see an x plus 2 in the numerator, x plus 2 in the denominator. So I'm just going to cross them out. They reduce. I write everything that's left over exactly how it looks. I don't simplify. I just rewrite it. Now, for the middle, you got the x plus 2, x minus 2 times 7. I'm going to keep it simple since nothing simplifies here in regarding like denominators. I'm just going to write a 7 out front and then the x plus 2 times x minus 2. So I'm just going to rewrite it, put the 7 out front. For the fraction on the right, remember it's over 1. So I see the x minus 2 in the numerator, x minus 2 in the denominator. So I know they reduce. And I get x plus 2 times the quantity x minus 22. So in the first step, I did exactly what I needed to do, which is reduce all denominators. So now I'm going to go ahead and just figure this out. I see a bunch of sets of parentheses. It looks linear right now. All right. Now I say right now because I could see what's going to happen. All right. But I'm going to just go ahead from left to right and just distribute. 7x times x, 7x squared, 7x times 2, negative 14x. And right there, the first move I made, this problem that I thought might have been linear, now is quadratic because I see the x squared term. So I'm already thinking, okay, once I do all this, I'm going to set everything equal to 0. Like that's how fast I can move with this. Next. Now, some of you may be asking, well, why did you write the 7 there first? And I'm going to show you. Right there highlighted, that is the factored form of difference of squares. X plus 2, x minus 2. So, since that is the factored form of the difference of squares, the question becomes, well, what originally was it? And originally, it was x squared minus 4. Okay? Equals. Now, on the right-hand side, I'm going to actually have to distribute. So I get x times negative 22, and I'm going to do it off to the right here. Just write my answers. X times x is x squared. X times negative 22 is negative 22x. So I'm done with that. Now I will distribute the 2. 2 times x is 2x. Put it directly underneath. 2 times negative 22. Negative 44. So when I combine everything, that gives me x squared minus 20x minus 44. So far, so good. I need to take this one step further because I still have parentheses in the middle. So I'm just going to rewrite everything and just distribute the negative 7. So I get negative 7x squared and positive 28. All right. So we get a bunch of terms on the left and a bunch of terms on the right. I'm just going to group things on the left and then group things on the right if I can, just to kind of, get this to look a little bit simpler. Now on the left-hand side, 7x squared minus 7x squared. They actually cancel out. That's great. So on the left, I have negative 14x plus 28. On the right-hand side, I have x squared minus 20x minus 44. And once again, I know this is still quadratic because the right-hand side of the equation has the x squared term. So I need to move everything to that side and set it equal to 0. So I'll add 14x to both sides first. That gives me 28 equals x squared minus 6x minus 44. Last, I'll subtract 28 from both sides to give me 0 equals x squared minus 6x. And that's going to be minus, oh, that's great, minus 72. That looks really good. Now, I have no GCF. I have 3 terms with a leading coefficient of 1. I'm going to go directly into this. So I put my binomials. I write my signs. Now I'm just concerned with the factors of 72. 7 and 2 is 7 plus 2. Yeah, so that'll work. Excuse me. I know if 5 doesn't work, does a 6 work? And what do you know? What do you know? As soon as I wrote the 6 and 12, I was like, ooh, I could stop. Because I know one of the factors is negative. One of the factors is positive. But I need them to combine to give me negative 6, which is my middle term. The only way that occurs is plus 6 minus 12. So now I have each term, each factor, I set them equal to 0. And I find that x equals 12 and x equals negative 6. However, we need to guarantee that these are the solutions. And why am I saying that? If I zoom out and I look all the way at the beginning of the problem, notice I have variables in the denominator, x plus 2 and x minus 2. I know that x it can be numbers, but the only values of x that I do not want is negative 2 and 2. Those are the 2 values I want to avoid. So when I did all of my math, which was a lot here, okay? When I did all my math, and I funneled it all the way down, I came up with x equals 12, x equals negative 6. And I feel really good about them because neither are x negative 2 or x equals 2. So I'm good. Does that make sense, everybody? Are we all on the same page? All right. Ouch, Artie, don't do that. So real quick, let's do one more problem. This will be the last one of the day. It's going to be another solving, so we might as well just do an easy solve. Where'd you go? Okay, hi. So, solve the absolute value. 2x minus 1 equals 7. Now remember, when you're solving absolute value equations, and that's pretty, I mean, you know this is absolute value because you see the signs. I mean, that's pretty simple. So when you solve this, the first thing you want to do, isolate the absolute value. It's already isolated. Second, ouch. When you're solving the absolute value, that A on the left-hand side, in fact, I'll write it like this. A must be positive. So this number on the opposite side has to be positive. For us, it is positive. That is good, which means we are allowed to go ahead and rewrite as 2x minus 1 equals 7, or 2x minus 1 equals negative 7. Okay? So from here, I just solve each little problem. So I'm going to add 1 to both sides. That gives me 2x equals 8. Then I'm going to divide both sides by 2 to give me x equals 4. For the second half of the problem, I subtract, or I add 1 to both sides again. That gives me 2x equals negative 6. And then I divide both sides by 2 to give me x equals negative 3. Artie, you okay? You good? So, that is it for me today.